Hey everyone, welcome back to the wonderful world of calculus. Last lesson we talked about the derivatives of certain trig functions, specifically sine, cosine, and tangent. Today we're going to be talking about the other three, the reciprocal functions, the secant, the cosecant, and the cotangent. Now if you remember from the last lesson, the derivative of tangent was secant squared, and we developed that by rewriting tangent to equal sine over cosine. So we're going to use the same kind of idea today to figure out the other three trig functions, okay? So with that said, again, our goal is to prove the derivatives for secant, cosecant, and cotangent of x. So let's go ahead and take a look at the first one I have here, the derivative of secant. So we have d dx of secant of x, and we are looking to find that derivative. Well, I don't know secant. I don't know the derivative of secant, so I have to revert to something that I do know. And so I can rewrite secant as a reciprocal of cosine. So it's the derivative of 1 over cosine of x. And then we can use our quotient rule to figure out that derivative. So using the quotient rule, the derivative of the top is 0 times the bottom. I'm going to go ahead and put parentheses around these things just so everything's good. Times the bottom, which is cosecant of x, or cosine of x, not cosecant, cosine of x, and then minus the derivative of the top or the bottom. So the derivative of cosine is negative sine of x, and then times the top, so times 1, all over the denominator squared, so cosine of x squared. So we can simplify this a little bit. Obviously 0 times cosine cancels out. Negative times negative sine times 1 is just going to be sine of x on top, and we have cosine squared x on the bottom. So that is the derivative of secant. But that's not the standard way of writing it. We want to be able to simplify this so that it is not a result of a quotient, a fraction, that it's a result of multiplication instead. So we would write this as sine of x times secant squared of x. So that's one way of writing it. The other way of writing it is to identify that sine over cosine squared is the same as saying sine of x over cosine of x times 1 over cosine of x, right? So I just broke down the denominator. And then since we know sine over cosine is going to be tangent of x, and then we don't want any fractions here, so we're going to rewrite that as secant of x. So we can see that all of these are equivalent in their nature. Now, how do we go about memorizing this? Well, we know how to develop it. It's pretty straightforward. Just use the quotient rule. But how do we memorize it? The standard way of seeing these things is so that it's a product, first of all, so we don't want a quotient. And the second thing is we want to try and reduce the number of exponents. And so in this case, we have a power of 1 and a power of 2. So in a sense, that's a power of 3 all put together. Whereas here we have a power of 1, a power of 1, so a power of 2. So generally, the way it's written is written like that. So the derivative of secant x can be represented in all different ways, but this is the way that it's normally seen, okay? So we would say that the derivative of secant x we'll write as secant x times tangent of x. All right, and I just rearranged the multiplication there because that's normally how it's written. Okay, let's go ahead and go through the other two functions. And our goal is to try and figure out a pattern here, or see something that will help us memorize these things. So if I want the derivative of cosecant of x, well, we're going to rewrite that as the derivative of 1 over sine of x. And this one's actually a little bit easier to see because sine, right? So quotient rule again, the derivative of the top is 0 times the bottom, which is sine of x, minus the derivative of the bottom, which is cosine of x, times the top, which is 1, all over the bottom squared. And then we can simplify that a little. Again, that cancels out. The top is left with negative cosine of x over sine squared x. And so we can write it like that. But again, that's got a power of 3 in a sense, and it's a it's a quotient, it's a fraction. We don't want to write it like that. So what we're going to do is we're going to separate this to be negative cosine of x over sine of x times 1 over sine of x. And then that would be, right here, that would be negative cotangent of x times cosecant of x. And so you can see there, it's kind of related. It's kind of related, okay? In that, well, let me go ahead and write it down here so we can see it. Equals negative cosecant x times cotangent x. And so we're trying to look for patterns that help us to memorize these trig functions. And again, if you don't have them memorized, and it's probably better that you can develop them than to just memorize them. Obviously, you want both. But if you don't have it memorized, you've got to be able to develop it, okay? So let's just look at those two relationships there and see something. Notice you've got sine and you've got cosine. Let's just focus on the trig functions that don't have a co in front of it. So you have sine, you have tangent, and you have secant. Sine, tangent, and secant. And then you have cosecant, cotangent, and cosine, right? So these are all reciprocals to each other in a sense. But let's just focus on, let's just focus on the idea of the non-co functions. Notice that secant, the derivative of secant, doesn't have a co in it. Secant has secant in it. The derivative of secant is secant tangent. Secant tangent. Secant, the derivative of secant is secant tangent. But if we look at the cosecant, we can see that it's got a bunch of co's in it. Cosecant, cotangent. So if it's cosecant, it's got a cosecant. It also has a cotangent. So they both have kind of a tangent thing going on times whatever their original function is. So secant, secant tangent, cosecant, cosecant, cotangent. That kind of goes together. Notice there is a negative out front of this guy, okay? Just trying to get you ideas to memorizing these things. All right, let's go ahead and take a look at the last one, cotangent, the derivative of cotangent of x. Well, we would write that as, we could write that as 1 over tangent, and that might be the easiest way to write this because you guys should know the derivative of tangent. And I'll do it a different way too. So quotient rule, derivative of the top is 0 times the bottom minus the derivative of the bottom. The derivative of the bottom is secant squared x times the top all over the bottom squared. Okay? And then simplifying that a little bit, you end up with negative secant squared x over tangent squared x. Again, I want to try and reduce the idea or get rid of the idea of fractions. So what I'm first going to do is rewrite secant on the bottom. So that would be cosine squared x because the reciprocal of that. And then tangent is, remember, sine over cosine. But because this is in the denominator, we're going to flip that over and say cosine squared over sine squared. Okay? So cosine over sine is cotangent. Because that's in the denominator, it flips and makes tangent. So we can see that the cosine squared and the cosine squared cancel out, and we're left with negative 1 over sine squared x. And then because we don't want the fraction at all, we'll simplify that to negative cosecant squared of x. And so we have our derivative of cotangent, which is negative cosecant squared of x. I'm going to show you a different approach to that produces the same thing. If I want the derivative of cotangent, remember cotangent is the same as cosine of x over sine of x. So if we use the quotient rule on this, the derivative of the top is negative sine of x times the bottom, so times sine of x, minus the derivative of the bottom, which is cosine of x, times the top, which is cosine of x, all over the bottom squared, which will be sine squared x. Now the top can simplify. I'm going to factor out a negative 1 from both of those, so that'll be negative times sine squared x, okay, and then plus cosine squared x, right? So I factored out a negative and I just put those together, over sine squared x. Sine squared plus cosine squared is 1, so we end up with negative 1 over sine squared x, which is again negative cosecant squared x. So there's lots of different ways to approach these things. You know, as long as you're going down to the simplest form, you're going to get the same answer here. Again, normally it's not going to necessarily ask you what's the derivative of cotangent specifically. It's going to ask you what's the derivative of cotangent at a point. And so you can use the unsimplified form and then plug in the value of x into that if you need to. But you really need to get down to memorizing these things. But again, make sure you know how to develop them before you memorize them. Okay? Now, let's go ahead and try and make another connection here. Let's go back and review a little bit. Remember the derivative of cosine of x is negative sine of x. The derivative of sine of x is cosine of x. And the derivative of tangent of x is secant squared of x. So those are your 6 trig functions. We will get into the inverse trig functions later on, you know, arcsine, arccotangent, and all those kind of things later on. But these are the basic 6 trig functions. Now, how could we see this? Well, what do we see? Some other relationships. We already made the connection that secant is secant times tangent, and cosecant is cosecant times cotangent. There's a connection there with the negative. The derivative of cotangent is negative cosecant. Okay, let's go over here and try and make a comparison between our reciprocal trig functions and our regular trig functions. If I look at tangent, what do you see? The derivative of tangent is secant squared. The derivative of cotangent is cosecant squared. So secant, cosecant. Tangent, cotangent. There's a relationship there. And then, of course, there's a negative out front there. Notice this also. Anytime you have a cofunction, cosecant, cotangent, cosine, you have negatives out front. So any co-trig function has a negative. Any non-co trig function, sine, secant, and tangent, there is no negative. So these are just ways to kind of categorize them and put them in your brain so you can help remember them. Okay, so there's the 6 trig functions. And I'm going to kind of skip this because I want to make sure we get on to something else here. Okay, let's do some applications of this stuff. First things first, the jerk. The jerk. He's a jerk. She's a jerk. Everybody's a jerk. No, jerk means something very specific in calculus, specifically talking about the application to physics and particle motion. We already know that velocity is the derivative of position, and acceleration is the derivative of velocity. The jerk is the derivative of acceleration. Okay, it's the third derivative. Okay, so if you go around calling people a third derivative, you're really calling them a jerk, but they wouldn't know it if you did. So, you know, I'm not suggesting you do, but you know, it's funny. It's calculus humor. Anyways, the jerk is the third derivative of position. It's the derivative of acceleration. So going back to your car and understanding the context there, you have velocity. Velocity is basically your speedometer, or what your speedometer says. I'm going 30 miles an hour. I'm going 40 miles an hour. Obviously, that's speed, not velocity, but they're related. Okay, so the number on the speedometer is your velocity. The needle moving is your acceleration. So you have a positive acceleration when you see that needle going up. You have a negative acceleration when you see that needle moving down. Okay. The jerk is how quickly that needle moves. Okay, so if it's moving and then all of a sudden, the needle starts moving faster, then you have a jerk. You have a non-zero jerk, and that's what throws you back in the car, right? The acceleration changing, the change in acceleration is what throws you back in the car. It's not just that you're accelerating, it's that your acceleration is increasing, okay? Or if your acceleration is decreasing, that's what's kind of throwing you forward a little bit. So that jerk is what gives you that feeling, Okay, so with that said, again, the jerk is the third derivative to position, or it's the derivative of acceleration, or you could also say it's the second derivative of velocity. So let's go ahead and take that and use it to answer maybe a couple questions here. And I might have mentioned the jerk in a previous lesson. I don't know exactly. But in number 1, it says find the jerk of s of t. So s of t is equal to sine of t. And we're looking for, so s is position, we're looking for the jerk. So the first thing is we got to find the velocity. Oops. So velocity, remember, is the derivative of position. Derivative of position is cosine. And then the derivative of velocity is acceleration. So that's the derivative of velocity. So the derivative of cosine is negative sine. Okay, those are memorized. And then the jerk is the derivative of acceleration. So what's the derivative of negative sine of t? Well, we take the constant out, the constant multiple out, ignore it. What's the derivative of sine of t? It's cosine of t. And then we'll bring the constant back in and multiply it back in. Remember, this is a circular thing. I said this the other day. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. And the derivative of negative cosine is sine. That just kind of makes sense. It's a cyclical pattern there. So our jerk is negative cosine of t, our jerk function. Number 2, it says find the equation of the tangent line to y equals tangent of x minus 2 at x equals pi over 3. So y equals tangent of x minus 2. Now I should put parentheses around that to clarify. And we are looking for the tangent line when x equals pi over 3. All right, so first thing we have to do is find a point. So our point is going to be plugging in pi over 3 to that. So that'd be y equals tangent of pi over 3 minus 2. Well, let's see, tangent of pi over 3 is going to be rad 3, I believe, minus 2. So my point is pi over 3, comma, rad 3 minus 2. Don't get overwhelmed by that. That's what it is, okay? The next thing we have to do is find the derivative. So y prime, well, what's the derivative of tangent x? The derivative of tangent x, let's see. That is not a cofunction, so the result will not be a cofunction, right, for tangent. Or it won't be negative, I should say. So we know it's going to be a positive result. And the derivative of tangent and cotangent is our secant, cosecant squared issues. So the derivative of tangent is secant squared of x. And then the derivative of negative 2 is 0. So to find the slope, we're going to plug in pi over 3 to that. So that becomes secant squared of pi over 3. Now, I don't have my secants, cosecant, cotangent memorized here, so I can rewrite this as 1 over cosine of pi over 3. And I do know the cosine of pi over 3. Cosine of pi over 3 is going to be 1 over 2. So I end up with 1 over 2 squared, right, cosine squared. And so that becomes 1 over 4, and that reduces to 4. That simplifies to 4. So that's my slope of my tangent line. So the equation of my tangent line is going to be y minus the y value. So I'm going to put parentheses around that because that's a sum or a difference, equals the slope, which is 4, times x minus pi over 3. So that is the equation of my tangent line. Let me double check my work by checking the answers here because I don't want to give you false information. Notice I rewrote it a little bit different here. I distributed that parenthesis, so I got y minus rad 3 plus 2, just distributing that parenthesis, and then the other side's the same, so we're good. All right, let's go ahead and go on to our last problem. We got a short lesson today, actually. I know that they've been running a little bit long if you've been following the sequential order of things, and hopefully you have, because you don't want to miss out on a concept that I talked about in a prior lesson. And then when we get to something, you know, I assume that you know it when we're talking about it. All right, you should probably pause the video and see if you can answer this question on your own before I do it. All right, we've got f of x equals 3 cosine of x minus 4. And it's saying, when is the slope equal to 3 over 2? When is the slope equal to 3 over 2? Well, I want to translate that into calculus talk. The other word for slope is derivative. When is the derivative equal to, what is it? 3 over 2. So we want to know, when does f prime of x equal 3 over 2? That's the question. When does f prime equal 3 over 2? So the first thing we have to do is figure out what f prime is. So f prime of x is equal to, well, that's a constant multiple, so I'm just going to carry that down, times the derivative of cosine. So the derivative of cosine is negative sine. So I'm just going to put that negative out front here. So I got negative 3 sine of x. And then the derivative of negative 4 is just 0. So I've got f prime of x there. And then we want to know when the slope is 3 over 2, or when the derivative is 3 over 2. So I'm not going to take 3 over 2 and plug it into x. I'm going to set the derivative equal to 3 over 2. So we say 3 over 2 equals negative 3 sine of x. And then we solve this. This is not a calculator problem. You should be able to do this without a calculator. So to do this, we're going to divide by negative 3. When I do that, I end up with negative 1/2 equals sine of x. And to solve for x, I would normally do an arc sine operation to get x by itself, and that's fine if you think of it that way. But I actually think of it better this way. Solving for x, when does sine equal 1/2? Well, sine equals 1/2 when we have 60 degrees, or pi over 3. No, I'm sorry, that's wrong. Sine equals 1/2 when we have pi over 6, which is 30 degrees, okay? Which means over here, and over here, all the reflections of that. And we're looking for when sine is negative. So that would be below here. So we're looking for this guy or that guy. So it's going to be 7 pi over 6, or it's going to be 11 pi over 6. Now we have to check our interval, and our domain is from negative 2 pi to 2 pi. And so we have the 2, what do I have here? I have something wrong here. 7 pi over 6 and 11 pi over 6 are my two answers within the domain of 0 to 2 pi. Then we have to go backwards. So again, we want the negatives. So that's going to be here, and it's going to be here. So that's going to be negative pi over 6 and negative 5 pi over 6 as our answers. So those are the 4 places where the derivative of f is equal to 3 over 2. Let me double check my work to make sure that is correct. Negative 5 pi over 6, negative pi over 6, 7 pi over 6, and 11 pi over 6. So you can see as we go deeper and deeper into calculus, more and more is going to be expected of your trig skills, okay? So really we don't go way deep into it, but you're going to need to know some basic things like your unit circle off the top of your head. You're going to need to know the relationships, the trig identity, sine squared plus cosine squared equals 1, sine over cosine equals tangent, all your inverse trig functions, so how secant and cotangent relate to the original ones. And then obviously you can see taking the derivatives of all those. We just did that a few minutes ago. But that's going to be critical, understanding your unit circle front and back with your eyes closed on your worst day. You should be able to rattle those values off pretty easily and how they apply. But if you have any questions for me, please comment below. And do me a favor and like and subscribe. Let's see if we can make this YouTube channel blow up, because the more people that can learn calculus, the better this world is going to be. And if I can have a hand in helping somebody out, hey, I appreciate the opportunity. So until next time, I'll talk to you later.